Hey, so now we've come to our last and final part of the sequences chapter. And now we have our last sequence or pattern called cubic sequences. Now, the term cubic sounds very familiar. Something to do with 3? Well, that is correct, yes. So, cubic sequences are terms that could be identified by its third difference. So you would notice that the third difference of a cubic sequence would remain constant, and you could further approach it and solve your nth term. So let's get to the application of mathematics here. So what happens is here is similarly to how to the approach of quadratics. In order for us to solve each variable constantly, we have to use a constant formula, and that goes by 2a, 3a plus b, and a plus b plus c. Now, you need all of these fundamental algebra skills to be strengthened or emboldened. And for this occasion, we have different terms. So we have 6a is equal to our third difference. And then we have 12a plus 2b is equal to our first term of second difference. Then we have 7a plus 3b plus c equal to our first term of our first difference. And then we have simply a plus b plus c plus d as our first term of our original sequence. Now with this, let's get into proper sequences. So number one, I have a small and quick example. Alright, so the terms here followed by 4, 14, 40, 88, and 164. Now let's start off by finding the gaps of each. So 4 to 14 is plus 10, 14 to 40 is plus 26, 40 to 88 is plus 48, and 88 to 164 is plus 76. Now let's find its second difference. So 10 to 26 is plus 16, 26 to 48 is plus 22, and 48 to 76 is plus 28. Now let's find our third difference. And remember how I said the third difference will always be constant. So let's see how it goes. 16 to 22 would be 6. 22 to 28 would be 6 as well. So now, as I said, the third difference will always be constant, and I guess I'm right. So now let's go to the application bit and to find the nth term. So as the formula given on top, we have to find the values of a, b, and c, and d to form our proper nth term formula. So let's just write this down, the formula here. So bn squared plus cn plus d. It'll be much easier here. So now so how would we find a? So simply what we do here is use the formula. So how I said is 6a, and that is the third difference. That is here. So let's first start off saying 6a is equal to 6 and a is equal to 1. So 6 comes from the constant value here. Now let's find b. And b follows by 7a. So b follows by 12a plus 2b. So 12a plus 2b should be equal to the first term of the second difference. So now let's use the values we have so far. So 12 into a, so a is 1, plus 2b is equal to 16. So this is what we have so far. Let's simplify this even more. So we have 12 plus 2b is equal to 16. So 2b is equal to 16 minus 12, which is 4. So B is therefore equal to 2. And once again, let's solve for C now. The formula here is 7A plus 3B plus C. So 7A plus 3B plus C as follows. So 7 into 1 plus 3 into 2 plus C should equal to 10. So 7 plus 6 plus C equals to 10. That's 13 plus C is equal to 10. So therefore C is equal to negative 3. Now with that given, let's now find D. This becomes 4. So that's this. So A plus B plus C plus D, and that should equal to the first term of the original sequence, which is 4. So we know that A is 1, and B is 2, and C is negative 3, and D is unknown. So let's find it. So that's 3 minus 3, 0, plus D is equal to 4. So therefore D is equal to 4 minus 0, which is 4. Now with this, let's input all these values into the formula. So of an cubed, so that's plus n squared plus n and plus d. So let's input the values of A. So A is 1, B is 2, C is minus 3. So C is minus 3n, and D is 4. So this is our final formula. Now let's see if it works accordingly. Let's find the value of the first term. So let's basically input n as 1. So 1 cubed plus 2 into 1 squared minus 3 into 1 plus 4. So that's 1 plus 2 minus 3 plus 4. So 3 minus 3, 0, plus 4 becomes 4. And that is our first term of the sequence. Now let's recheck once again by a different term to prove that the formula is real. So let's use our third term as an instance. So 3 cubed plus 2 multiplied by 3 squared minus 3 into 3 plus 4. So that's 3 cubed is simply 27, plus 2 into 9 is 18, and 3 into 3 is 9, and plus 4. So 27 plus 18 should be 30, and then we get 40, then 45, and then we get 48. So 27 plus 18 is 45. Minus 9 plus 4. So 45 minus 9 is 36, plus 4 is equal to 40. And let's see if that's our third term. Yep, there we go. That is our third term. So now we can say that the formula works accordingly and works as applied.